Okay, so for this problem, it's talking about finding the vertex and the equation of the axis of symmetry and to graph the function. So let's first look at the function. It's in the form f of x equals, in parentheses, x plus 4 squared. So the little square part tells us it's quadratic. It's in a different form than we might be used to, though, at this point. So we're used to ax squared plus bx plus c, and this is in a different form. I call this kind of the second form, or form 2. I've called it in class before. So this form is actually a nice form if it's already in this form. It's actually the best form to have it in if we're trying to graph it, because we can pick out some parts if we know what to look for. So the first thing to look for is what's in front of the parentheses. That's your a. If there's nothing in front of your parentheses, that means your a is 1. But what that tells us, first of all, is if the parabola opens up or down. It also tells us how wide the parabola is going to be. If it's positive, it's going to open up. If it's negative, your parabola is going to open down. Also, if it's a number between 0 and 1, it's going to flip the parabola. Well, it's going, sorry, not flip it. It's going to make it a wider parabola than our parent function. And then if it is some number bigger than 1, it's going to make it skinnier. So let me show you a little example I've made here. Called it shifting graphs. Can't see that up here. I have a little thing called high-vo that I use in my class as well. I'll talk about that in a second. But look right here. Here's the original parent function. I call it the parent because it's just the most basic of all the quadratic functions. It just goes right here through the origin. That's our vertex. The little tip of our parabola is called the vertex. It goes right there. It's not too wide, not too skinny. Notice some points it goes through is 2, 4, or negative 2, 4, or 3, 9, negative 3, 9. Those are some points it goes through. Look what happens if I change this number. So now I'm going to compare my original to this new one over here. Let me change this number, let's say, to a 4. So that's like if we had a 4 in front of our parentheses of our equation. And look at what happened to our new function compared to the original. It's a lot skinnier. So that's what the a does. What if I change it to a negative 4? Then it would flip the whole function over and make it skinnier. So whatever's in front of the parentheses when it's in this form, that's what is going to tell us what direction it's opening and if it's flipping up or if it's wide or skinny, opening up or down. Let's go to the next part then, and that's what's inside the parentheses here. That's going to be a horizontal shift, and that's where my little high comes from high-vo. HI stands for horizontal inside, to help you remember that if you add or subtract something on the inside of a parentheses, it's going to shift your original function or your parent function horizontally. But it's actually going to go the opposite way of what you'd think. So let me change this back to the original. So if I add or subtract something on the inside of the parentheses, it's going to go kind of the opposite way of what you would think. Let's say I added a 6 on the inside of the parentheses. You might think since it's plus a 6, it's going to move it to the right 6. But watch what happens. It actually moves it to the left 6. So inside the parentheses moves it horizontally, but it's kind of the opposite way of what you'd think. If it's a plus, it's going to move it to the left. If it's a negative, so subtracting 6, it's going to move it to the right. When you add a negative 6, that's the same as subtracting 6. So we move it to the right. So just remember, horizontal inside moves it opposite way of what you'd think. So let me go back to the original on that one. Let's go back one more time here, because whatever you add on the outside of the parentheses is going to be a vertical shift. So that's what this VO stands for in my little phrase, high-vo, vertical outside. So if you add or subtract something on the outside of the fraction, it's going to move it outside of the parentheses or of the function. It's going to move it vertically. So let's look what happens if I add or subtract something vertically. Let's say I add 5. That is going to move it the way you would think. It's going to shift everything up 5 units. If I would have subtracted 5 or added a negative 5, it would move my whole function down 5 units. So you always want to start right here with the parent function and shift it from there. A lot of books call it transformations, and that's what it is. They're transforming the parent graph into this new graph. So let's look at what the problem said on this one. It was said x plus 4 in a parentheses squared. Notice it didn't add anything on the outside of the parentheses, or if you thought about adding, it was basically like adding a 0. So it did not have a vertical shift, it only has a horizontal shift. Also, it was not wider or skinnier, or it didn't flip up, it did not flip it down because there was nothing in front. All it did was add a 4. So the vertex is going to be over here at negative 4, 0. Other than that, it looks exactly like the parent, other than it's been shifted to the left 4 units.